GTC, first and foremost, is our opportunity to highlight the amazing work that our engineers and our teams here at NVIDIA have done all year long. It's always been filled with the most amazing demos in deep learning, supercomputing, and computer graphics. What was different this time was that we used our own platform, Omniverse, to create the amazing visuals and demos for all aspects of the keynote.
Here it is.
Slides for any keynote presentation are critical. We use these visuals to convey extremely complex ideas to everyone. In the past, we used to use PowerPoint to create these slides. This year, our slides are virtual worlds, completely created and rendered in Omniverse.
GTC 2021 was a beast. There were over 100 slides that the team and I worked on, and it was a lot.
Because of the type of information that we get, everything is super technical. We have charts, we have images, we have systems, we have a whole bunch of things that we need to fit normally on one slide that needs to make sense to the audience. So it's almost like solving a Rubik's Cube, where it's an extremely complicated problem that we have to solve. How can we visually tell this story and make it interesting for the audience? Once we get the slide figured out and figured out what we want to say, that's where we bring in the 3D team and start creating mock-ups for them. And mock-ups can range from Photoshop to PowerPoint to kind of getting the general visual idea.
When I first joined NVIDIA, we were still using CPU rendering, and each render would take quite a long time to finish. And this year, we full-on went into Omniverse. So everything in the Keynote was created in Omniverse using the real-time engine. And that allowed us to quickly make changes.
We started Omniverse knowing full well that we're not going to be able to build the metaverse ourselves. There are already great tools out there that people use every day in every industry that we want people to continue using. Omniverse was built with the idea that we can take these existing tools and new ones that will come into the future and augment them with our technologies.
I would prepare my assets still in Maya, but then I would export it out and I would do the layout in Omniverse. It's quicker because you see in the viewport right away the shaded view with the lighting interaction, and it's very speedy. Content changes come pretty frequently. I created all these different panel templates that they can just use and insert the content, and it really helped us to deal with the amount of work that was coming down the pipeline.
We went through probably 50 different iterations for the template that we used, and it ended up being something really beautiful.
One of the biggest challenges we faced with the slides were very large panels that sat behind the hardware. And those panels were made of this black lacquer, piano lacquer, that were super, super shiny. So anything that you placed anywhere near it, it would completely reflect it. We had to be very, very careful about where we placed those lights.
Another slide that we had a challenge with is the whole idea behind Omniverse itself. It's very, very difficult to take all of the information of how Omniverse works and the apps that it uses and the collaboration and everything and show that visually on a slide. For the nucleus part of the Omniverse slide, I think that alone was 15 different variations.
Because it's so fast and interactive, you can hop on a Teams meeting or a Zoom call with a designer and have them watch you, and they can make changes on the fly.
What if you move like more to the right so then more of the card is lit up?
Okay, sure.
And then you're able to ask all the questions you want at once and see the results, compared to almost having to work on pieces by themselves because you can't do the whole thing at once because it's that many more emails and iterations. We had 2 slides in the deck that were icons and text, and that's it. You have to find the balance between, okay, this looks elegant, but does it look 3-dimensional? And that was kind of a struggle that we went back and forth on.
The designers for the slide wanted to bring those icons into the 3D world. So I was able to do the geometry in Houdini, export it into Maya, and once I was able to have the 3D geometry, I was able to apply my MDLs, this really nice, beautiful gold material, to those icons and then port them over to Omniverse and have them live in a very real environment. So they're reflecting on the floor, they're reflecting anything that's beside it. And because Omniverse is once again so blisteringly fast, I was able to get feedback from the designers.
It was definitely one of our big line art challenges that we didn't think was going to be as complicated because it's just icons, but the end result looked really, really beautiful.
There's like this triad, this triangle. You have the model, you have the materials, and you have the lighting. When all three of those elements are in sync, you get a beautiful render. They marry so well in Omniverse because of the MDLs.
MDL, our material definition language, which we've been investing in for the better part of a decade, is a big part of Omniverse. Every aspect of physics that affects matter should be described in a material. They're all part of the super definition of a material.
So materials for this particular GTC Keynote was crucial that they all look photorealistic, that when you have a diffused material, it looks like a diffused material. When you have a highly reflective material, it looks just like that. And it's beautiful, especially when you're really trying to highlight the materials that the industrial design team have worked tirelessly over.
The goal of the DGX station animation is to celebrate our industrial design team and their amazing work. Unfortunately, we only had 3 weeks to go from a detailed CAD model to a beautiful cinematic.
We had several people working with me to develop the look and feel of the animation, the lighting, camera angles, and such. We have only so much time to build, refine, iterate. So we set up the entire scene within Omniverse. Omniverse allowed me to make changes fairly quickly, either in Maya or in Omniverse directly. We just bring in the props from Maya through the Omniverse converter and place the lights according to the needs, the look, and the feel of the project. The CAD file was already prepped before this animation. We spent about a day taking the DGX station and converting it over to Omniverse MDLs. Building out the environment took roughly 3 to 4 days. All in all, that process normally takes about a week, taking the CAD file to a usable model, and then about a day or two to get the shaders applied and then rigged up for animation. With an animation like this, moving a light just a little bit has a huge impact, and then being able to see that impact through the entire animation is really advantageous. With other packages, I would have to set up the scene, compose lighting for what I would assume would be correct, then render out a frame, wait 10-15 minutes, and then get a result, and then adjust lighting accordingly. Omniverse last year wasn't as stable as it is now. It's gotten better because of the feedback we've had with the Omniverse team, the ability to insert features specifically for our team. During development, we ran into a bug where the motion blur wasn't working the way we expected it to. The deadline was coming up quick within the next couple of days, so we reached out to the Omniverse team.
A few of us made some suggestions. I made a suggestion to Nacho on how we can do a quick hack that would get us actually extremely high quality motion blur. It's typically not done this way because the rendering is slower when you do it, but our renderer is so fast and it's so accelerated that we could afford that. And it actually gives you a better quality motion blur. Nacho hacked that in to the renderer as a Python script in an hour or two, and it's still there.
Start to finish, it was roughly 3 weeks. It was a real crunch all the way through. You have a certain set amount of time, so it'll always be delivered in that time, but the quality is what you end up sacrificing. You have to start rendering sooner, so you have to make compromises as far as the look and feel and not have as much refinement. And in this case, we were able to use 10 machines to render the entire animation overnight.
So not only did we show off our photorealistic materials and lighting at this year's GTC, but we also highlighted our highly accurate real-time physics engine, PhysX. PhysX actually predates NVIDIA's acquisition of a company called Aegea. And with it, we got one of the world's finest teams writing physics simulators for real time. The primary focus of PhysX was to accelerate physics inside video games. But a few years back, it started becoming clear to us that the value of real-time high-performance physics is now more than just video games. We were starting to enter markets like robotics and autonomous vehicles. And with PhysX 5, the latest version of PhysX that we have that's integrated into Omniverse, we've been adding high-performance simulations for different aspects of physics that generally we don't see in real time.
In this year's GTC, we show all this amazing demo with all the physics technology, such as fluid dynamics, amazing FEM soft body simulation, and the highly accurate articulation system for robotic simulation and large-scale rigid body simulation in the GPU Accelerate platform. My favorite one will be the skeleton hand, picking up the cup, moving the liquid into one cup to the others. And the reason why I love that demo so much is because it's extremely challenging to simulate those scenes in real time. So for example, in this scene, what we're looking at is we have an articulate skeleton hand, and then each hand have a 5 fingertip, and each fingertip is a FEM-based soft body simulation. So we're using the constraint system and attach those fingertips into the rigid body, and using friction to lift up the cup. Each fingertip has a 6,000 tetrahedra, and inside the cup, that is our particle system TED. Just in that small amount of water, it actually have a 20,000 particle inside. Basically, why we are making this demo, it made us realize a lot of technical detail we have to address. For example, the fluid dynamic, because the particle is such a tiny particle, it's hard to make it stable in a cup. So normally, when you're doing the particle simulation, right, even though the particle, the simulation is not stable, which is mean the particle jumping around, but you can hide it by using a nice render on top of it. However, in that scene, we don't have a proper render in there. So if the particle is not stable, you will see like a bubbling effect in there, but you see the particle is extremely smooth. So during the process of making this demo, we actually improve our fundamental tech dramatically.
Physics to us is extremely important. We've had a renewed effort to not only make our physics extremely fast, but also make it extremely accurate. With games, accuracy and fidelity is not as important. But for tasks like robotics and training AIs, the fidelity is extremely important if the AI brain that we're building to put inside these robots learn physics in a world where physics works differently or incorrectly, not like the real one, they're not likely to be successful once we move their brains into the real world. When building modern factories, robotics are an essential element of the design. But the only way to really know that your design is correct is to test it out. And the only way to test it out today is to actually build it and then try it. With a digital twin, you get to make those design decisions very early in the process and have many iterations when it's still inexpensive and safe to do.
What we demonstrated, along with BMW, was a vision for the factory of the future, where we believe the tools and the workflows, the data, everything will be streamlined by connecting it all to our Omniverse platform. We are able to bring significant improvement in efficiency of the factory design, optimization, and operation.
The BMW Factory of the Future is a real-life plant located in Regensburg, Germany. This factory is gigantic. It's a monster. It's 600,000 square feet, and it's just packed to the gills with stuff. 2 billion triangles, roughly. There's tens of thousands of objects. There's thousands of materials, and all those materials are all PBR with multiple textures. There's hundreds of full-resolution cars and slings. There's 120 digital humans doing their digital human thing. There's autonomous robots learning about their environment, becoming optimal at what they do. Then there's a whole other section of robots that is being driven by data from the factory. No animation happening to their articulation. It's all just being fed straight from the factory into Omniverse. So data starts in its CAD package just like usual. You send it into Omniverse, and then as updates happen in the CAD package, Those updates are just sent into Omniverse, and it's not like the whole thing has to come over every time. It's just the differences that are sent at that point. So Omniverse has the capability to ingest E57 format point clouds, and it does it on the fly. So BMW was able to provide us E57s, and we just simply dropped that into Omniverse, and then we went through the process of updating, creating real-time lighting, creating real-time materials and textures to create a one-to-one digital twin of the actual factory, both in fidelity and behavior. And materials play a heroic role in that. NVIDIA's physically accurate MDL programmable shaders are purpose-built to represent the real world. For robots, in order for them to understand the world, that world really needs to be represented in a physically accurate way. And it goes way beyond form. Just because you have a good-looking 3D model really doesn't tell the robot anything. It needs to know color, reflectivity, roughness, meltiness, light emission, subsurface scattering. They all play crucial roles in the identification and the validation of proper materials of any given object or work set.
Traditionally, when we talk about materials, normally we're referring to the simulation of the physics of light and matter. But materials actually extend past that. We also want to simulate other aspects of physics, like sound and how it interacts with the materials in a building like this. So material definitions also apply to other domains outside of the visual spectrum.
People are really at the core of assembling a car. The way it works is that there are a bunch of stations along a line, and every station is responsible for putting things like the muffler or some other car part. So it matters how far they are from the thing, what tools they have to use to secure it. Being able to simulate those movements in the context of the digital factory. We had an Extend suit on. I was here in my living room. I was streaming that out through Motion Builder, which was connected live into Omniverse. And all of a sudden, I'm in the world and I'm able to say, okay, I'm having to lean over too far and there's too much strain on my back. And maybe that should be up here. And the order of the materials matters too. So being able to just simulate that over and over again till you really get the right process, it's a complete game changer. There are quite a few sleepless nights on this one. All those nights were always filled with a lot of laughter and camaraderie and making jokes, and it actually worked. So that was pretty fantastic.
Factories are moving towards mass customization. Gone are the days where the lines would just spin out same widgets. Now, consumer preferences are changing and consumers are demanding more and more custom designed products, but it's at scale. So the factories have to be highly reconfigurable. When a company like BMW has to rapidly reconfigure a factory line to manufacture a new line of cars, they have to keep in mind all these different optimizations of sequencing, timing, and the shortest path from point A to point B, the intralogistics. And these intralogistics are fulfilled by robots. So all this needs to be simulated before you reconfigure the factories. And that's where the digital twin in Omniverse would come into play. So you're able to quickly reconfigure the factories, find the most optimal configuration to produce the new line of cars, and then you go about designing it in the real world, and then you operate the factory.
DriveSim contains essentially a digital twin of certain parts of the world. We're taking certain areas, certain cities, and creating a virtual world that's a facsimile of the real one, where we can test our AIs that we're building to put inside these cars.
In order to create environments in DriveSim, we usually have two ways. One is the manual approach, and the other one is creating an environment from scanned data. So for GTC, we actually went with the manual approach. We first identified the entire Stuttgart route near Daimler facility. We identified 2 key locations, and for those locations, we downloaded the reference data, all the high-res aerial imagery and digital elevation model data. And then we used a third-party tool called MathWorks Roadrunner, loaded those data into that tool, and created an environment. So we built the road network, we built the terrain. What we have in Omniverse is we have a MathWorks Roadrunner importer that allows us to import that entire environment in one shot And when you ingest that entire environment, we do a lot of processing on the Omniverse side to make it very photorealistic. We replace certain assets with high-resolution models. We optimize many areas of the scene for ray tracing. We also enable randomization for synthetic data generation and also for testing drive behaviors, not just for camera, it's for multiple sensors such as LiDAR and radar. So a couple of challenges that we faced to create the environment for GTC. We have a large tunnel to build, and it was super difficult to get it right. So we had to drive within the tunnel, get lots of images, reference images or videos to see how the tunnel exactly looks from inside. And then we took all that information and then we had to model that tunnel from scratch. We went through the texturing, and the ray tracing engine did an excellent job in simulating all the bounce lighting. All the lights bounced within the tunnel, gave that global illumination. The sunlight was hitting just the right amount and illuminating the entrance and the exits of the tunnel. So it turned out quite well, but it was one of the challenges that we overcame.
The biggest challenge that we have worked with when working with the DriveSim folks is really meeting the performance needs that they have. A really important aspect of this is that we're using DriveSim to train these sensors, and we have to depict an accurate version of the world. The sensors have to believe that they're actually in the real world, so the accuracy of the lighting and the accuracy of LiDAR and radar have to be correct. When we're making DriveSim, it's really important to be able to make these really beautiful ray-traced images and to be able to do that in high performance. And so we build up high-performance representations of the scene that are very GPU-friendly. So when you have a Mercedes driving down the street, we also have little programs that are controlling the cars that tell them how fast to go and whether they need to turn left or right or stop at that stoplight. Then we feed that into physics, and then physics does the actual simulation of the vehicle and the response of the suspension. What should the wheel angle be? What should the wheel torques and brake torques be? We pull those results back, and then we feed those to the renderer so that we have accurate physical response. And so one of the things that's tricky here is because the DriveSim main loop has to be running at a really high frame rate, you have to be able to have the physics interaction happening and our other interaction happening, and we do that by having these things be asynchronous. I remember, I forget, this was maybe like 3 weeks out from when we needed to deliver recording, and we went up to record and the vehicles would all move, but their wheels all stay behind. It was fun to watch, but yeah, we fixed that bug.
Now, with this kind of accuracy, we could generate all the synthetic data with various kinds of lighting and randomization in place. And we proved that it works by using these training data and deploying it. And we saw the Eagle car could drive from point A to point B all by itself. It was all using training data generated from Omniverse for GTC.
The Factory of the Future and DriveSim demos really shows NVIDIA's passion for pushing ourselves to the limits. But we didn't stop there. Jensen challenged us to create a digital twin of his kitchen and also himself to be featured in the pivotal moment of the keynote. This kind of undertaking is the epitome of what GTC is. It combines everything that NVIDIA does in computer graphics, AI, and simulation. In order to pull this off, our creative engineering and research teams all had to work together as one.
Prior to COVID, NVIDIA was putting on large events and keynotes with Jensen on a stage in front of a large audience. Once COVID hit, we had to rethink what those keynotes would be.
Welcome to NVIDIA GTC 2020, our first kitchen keynote.
So Jensen challenged us to find ways to elevate his kitchen keynote. So we went off and created a 3D digital twin of his kitchen that we could find unique ways of bringing his kitchen to life. We took hundreds of photographs from every angle of his kitchen, pumped all of those photos through a photogrammetry application that would build a coarse model to scale. And that became the starting point in which our modelers would add a lot more detail and accuracy to the model. The kitchen is very complex. If you look closely, you're going to see like thousands of screws, a lot of hidden objects in the scene that are actually the fabricated components of the kitchen. I would say there's probably 6,000 to 8,000 objects in the scene, polygon-wise in the hundreds of millions. There are a few little Easter eggs that we put in there. There's a coffee grinder with an NVIDIA logo on it. The olive oil tin, the name was changed to Tau, which is one of the software products that we announced. And somewhere around there, a Lego Jensen's running around. So as part of the keynote, not only did we virtualize the kitchen, but Jensen challenged us with virtualizing himself. You'll see the kitchen disassemble, and when Jensen reappears inside of the holodeck, it's actually the virtual version of himself. He proceeds to introduce our new CPU, teleports away, and then the next time we cut back, we're back to the real Jensen.
I've been in visual effects for over 20 years, so creating a digital replica of somebody real is something I'm quite familiar with. But in this case, it's a little different. Unlike a film, we're able to capture as much data as possible of this person. We have a very minimal set, and everything else had to be done through AI to synthesize. We've been developing a lot of AI-based generation, animation, rendering technology, and that was the big push to see how far our technology can do with very minimal data of Jensen. We do need some scan of Jensen, a 3D scan.
We found a service that had a large truck, and inside the back of the truck were hundreds of DSLR cameras. We pulled that up to Jensen's house. He stepped into the back of the truck.
All right, what's the game plan? And 3, 2, 1. Guys, you can relax. I wasn't hurt just a little.
In a series of poses, took thousands of photos of him, and that was the base in which we constructed the 3D model. So once we had the model of Jensen, now we have to bring him to life. Two main components to bring him to life was the facial performance and the body performance. The facial performance was driven by our technology audio to face.
The beige hue on the waters of the lock impressed all.
An automated way of using an audio clip to drive the facial performance of any likeness character. And that returned a pretty good result, but it wasn't pixel perfect and it wasn't photoreal. We then reached out to the video research team. They were working on a technology called face video to video. And what that would do is that would take a photograph of Jensen and map it to the animated CG version of himself. This vid-to-vid technology enabled us to bridge that uncanny valley from the CG model to a photorealistic, convincing version of himself full screen on camera.
Kevin is like the director. He planned the whole video shootings and the scene and where Jensen should be. Simon's scene is more like the main actor. They create a CG model of Jensen and to do the performance, acting, talking. And our team is more like the makeup man. We use AI to put fancy makeup on top of the CG Jensen to make it realistic. One challenge in render face, especially under the holodeck environment, is that a strong specular highlight on the forehead. To have a realistic rendering, the specular highlight should remain in the right position. It shouldn't rotate with Jensen. And this is a deep learning method. You don't have the physics to control how it looks like. We create room where the lighting is similar to the holodeck in our final CG world, and we have Jensen stay there, and we take a couple of videos, and it was about 3-4 days before the keynote, and we are able to quickly leverage the data to fine-tune our model and achieve better illumination control.
So bringing the face to life is just half of the battle. The body needs to reflect the vocal performance as well. So we were working on another technology called audio to gesture.
Amazing increase in system and memory bandwidth, the basic building block of the modern data center.
What this does is take the same audio input and output gestural qualities that are reflected in what he's actually saying. In order to do this, we hired an actor to learn Jensen's physicality by studying past keynote events. We had him get into a motion capture suit, record 8 hours of him reading past transcripts of Jensen keynotes, at the same time physically mimicking Jensen's performances. That 8 hours become the training set that would be driven by Jensen's unique audio delivery for the current keynote.
Now you actually just can provide a voice and it'll have body motion. We had so many variety of Jensen to pick from. We had a 21 version, and each time we do an update, there's 21 of them to choose from in different varying performance. It was actually getting to the point where I'm actually casting, because they were all performing well.
The performance will be loaded to CG Jensen's model to create the CG shots. And we take the video and turn the face part into realistic Jensen. The face part is then composed with the CG shots, and the final Jensen, including head and body, is put into the kitchen to complete the final production of digital Jensen. As an AI researcher, I come from a machine learning background, and I was not familiar with the movie production pipeline. An important thing for me is to feel the pain. How difficult it is to produce the digital human, and to kind of challenge myself how we can create tools to make digital human production a much easier process.
The virtual kitchen and virtual Jensen presentation was done in Omniverse, along with many other applications that help create the textures, some of the modeling as well. And that's the beauty of Omniverse. It's a collaboration simulation platform that enables us to work multi-directionally across all these applications, while we can build and develop custom technologies very quickly, especially AI-based technologies, which there isn't many platforms we can do that on today.
The beautiful thing about Omniverse is you don't have to give up those apps that you've known and loved. I still use Maya, I still use Houdini and Substance as well, but I'm also using something that can make it really, really fast to get beautiful results in almost no time.
To me personally, I feel the quality has increased and we moved into the photorealistic phase of look and feel.
The RTX renderer inside of Omniverse allows us to do real-time ray tracing in a way that I haven't seen in other things on the market. So I feel like the ability to be able to control our destiny with Omniverse and be able to build it to be something specific for what they need, I think gives us a lot of power.
We built Omniverse first and foremost for ourselves here at NVIDIA. We built it for our simulators, for autonomous vehicles and robotics, but also for our creative team. We started Omniverse with the idea of connecting existing tools that do 3D things together to build a sort of what we're now calling the Metaverse. We spend a lot of energy and time and blood, sweat, and tears to present it in the best light possible. If we do our jobs right and we build something as great as we believe it is, then I believe 20 years from now, we're still going to be using it, but it's going to be much more evolved. With so much groundbreaking stuff here at GTC 21, I really can't wait to see what the team does next year.
Welcome everyone. Thanks for tuning in to our documentary. We're really excited to be here to give you a sneak peek into what goes on behind some of the most important events of our NVIDIA year. So we have a Q&A panel here today with some of the key players in the development of the GTC Keynote, as well as the core foundational technology across the company. Michelle Liu is the director of simulation technology. She has experience over a decade working in the game development industry. She specializes in physics to networking to AI, and today she leads the PhysX team, bringing advanced simulation technologies to key NVIDIA platforms like Drive, Isaac, and of course, Omniverse. Ming Yu is here with us, distinguished research scientist with NVIDIA Research. He specializes in deep generative models and graphics. He's worked across some of our most pinnacle research projects like VigiVid, Face VigiVid, GauGAN, which is now NVIDIA Canvas, GANcraft, and just yesterday, he and his team won the real-time live demo competition with their new paper, I Am AI, AI-driven avatars made easy. So congratulations, Ming Yu. Next, we have Rob Bryant, a senior 3D artist on NVIDIA's creative team. He has many years of experience at some of the world's most major technology brands like Apple, Microsoft, and Logitech. We're very lucky to have him here. He has expertise in modeling, lighting, rendering, materials, and in all of his work, he celebrates ultra-realism, technical accuracy, and really refined craftsmanship. So super excited to have you. And last but not least, Rev, he's our Vice President of Simulation Technology and Omniverse Engineering. He has a long history before NVIDIA, of developing technology in the media entertainment industry. And for the past 2 decades, not to age you, but has been at NVIDIA.
It's okay.
Leading,
they can know I'm old.
leading our company's key game and simulation technologies, like from GameWorks to GeForce Experience, even Ansel. And the foundations of the Omniverse platform are really Rev's brainchild. And for the past years, him and his team have been bringing all areas of NVIDIA competencies and integrating them into the Omniverse platform. So welcome, everyone. To start off, wanted to start off with Rev. And so since we're at SIGGRAPH, I think it would be really pertinent to start off with kind of talking about the changes in the computer graphics industry. We've seen it here at the conference. We've seen it all throughout our keynote for GTC. Seems there's a new demand for computer graphics, and there's more use cases that aren't just media and entertainment. And so how has this new demand shifted the requirements for computer graphics, and how does Omniverse fit into this?
Very good question. I mean, if you go back to the origins of computer graphics and SIGGRAPH back to the 60s, when computer-aided design started to become a thing for manufacturing, and SIGGRAPH started showing up in the 70s, and for a while there, the primary driver for computer graphics and simulation were professional uses that for manufacturing, for design, for architecture, etc. But around the late 80s, early 90s, this shift happened where the forefront of computer graphics started being driven by entertainment, which is really cool. That's where I got my intro into all of this. I happened to be in Los Angeles at that time, a teenager, and fell in love with computer graphics, and Jurassic Park kind of put it over the edge. And SIGGRAPH became all about making movies. Soon after, we started trying to make this real time, and we used it for another form of entertainment, video games, which set the stage for NVIDIA to be what NVIDIA is now. We built our GPUs on the back of video games and entertainment, and that's where computer graphics has largely been advanced for the last few decades, for about 20 years. But a shift has happened in recent years with artificial intelligence coming onto the scene, coming back, powered by the same processors that we built for video games. We now see uses of computer graphics and simulation for virtually every industry out there, for everything that we're doing. We can't imagine how we're going to create the artificial intelligences that we need for robotics, for autonomous vehicles, for designing buildings that work in our new climate, with the changes happening to our world, how we're going to solve the world's problems without these technologies. So the market and the need for computer graphics has become much greater than entertainment. With that, the needs of the software and simulation technology, the platform, have shifted as well. It's not enough for things to just look right anymore and just be cool. We actually need for it to be accurate, a facsimile of the real world that's accurate enough so that we can make decisions about how we build things and how we design things. And I think we're starting to feel that here at SIGGRAPH. We're getting past computer graphics just being something that we do for fun and entertainment. Now it's essential for everything that we do.
I think that really relates to maybe Michelle, in the documentary we saw the extreme depth and complexity of the simulations that you guys did in just furthering your field. And then we got to see it in the physics montage in the keynote. And so, I would love to know what Omniverse has brought to the physics simulation field. What can you do with Omniverse today that wasn't possible before?
To me, right, I think the biggest impact of Omniverse has given to the field of physics simulation. Omniverse is a GPU accelerated platform. So we are able to use the computation power of GPU to perform high fidelity, large scale simulation in real time. So normally there are two key metrics to access to judge physics simulations, right? Performance and accuracy. It is hard to achieve both metrics. In the gaming industry, developers favor performance over accuracy because responsiveness is the key for campaign. However, for the robotic case, accuracy is key because engineers want the simulation to closely match the dynamic of a real robot. This might come at the cost of performance. For being a GPU accessory platform, Omniverse allows us to achieve both metrics. For example, with the newly added FEM-based deformable body simulation in Omniverse, we are able to simulate the FEM models containing hundreds of thousands elements in real time. Another great example is the robotic reinforcement learning. Most of existing reinforcement learning framework use a mixture of a CPU and GPU or TPU for the simulation and training. However, this kind of approach can easily become bottlenecked by data transfer overhead between host and device memory. To address this issue, we built an end-to-end pipeline for the simulation and reinforcement in SIGGRAPH. So the concept of an end-to-end pipeline is extremely simple. We just want to keep all the data persistently on GPU. We run simulation, we roll COX functions and the neural network all on GPU. This completely cut out the frequent host and device data transfer clocks between the host and device memory. So this massively improves training performance. So I would say that it's extremely powerful. Omniverse is a GPU accelerated platform.
It's really cool. And so what do you mentioned a couple of things in there on, the evolution from physics simulators for game development, and now we're going into robotics or autonomous machines. What's the next biggest challenge you're trying to tackle with physics simulation?
To me, right, with the GPU acceleration, I would really love to see us can scale up the simulation even more using multiple GPUs. So let's imagine something, right? If we are able to simulate massive flow simulations, such as reflecting the whole city in real time, where this kind of effect was previously only possible by offline simulation in the VFX industry, but now we can do it in real time. How cool is that? In order to the raw performance, we can leverage the massive computation power of the GPU to perform much more detailed simulation to enhance our simulation fidelity even more. So a great example of this is we can go down to the molecular level and simulate the electromagnetic interaction between atoms. So this has a massive number of applications in the field of healthcare and drug discovery. So being able to take advantage of the computation power of GPUs open up so many opportunities. I can't even describe it in here. So I'm really excited to see what our user will be able to build with Omniverse.
That's awesome. Well, I hope that we'll see some of that stuff at next GTC. No pressure. And so I think you had mentioned that Omniverse opens new potentials, opportunities for your field. And I think, as we saw in the documentary Mingyu, the platform kind of opened a whole new scope or area for NVIDIA research. You partnered with creative and engineering teams to create the virtual Jensen. And so how exactly has Omniverse expanded the opportunities or even the scope of your research areas?
So Omniverse provides a platform to let you impact the creative community with your research ideas. To have your trained deep learning model inserted to their workflow to assist the digital artists to give them superpower to accomplish their tasks faster and better. So my view is that an artist's work consists of two parts. One is the fun part, where artists exercise their creative minds to create amazing stuff. The other is the boring part, where artists exercise their muscle memory just to get things done. And I think AI can help on both ends through Omniverse. AI is all about learning patterns from data. So given training data of how artists perform those mundane tasks, we can train AI to automate this process to free their minds and muscles. And when AI is trained on huge amount of data, they tend to generalize better. So I think this AI model can be harnessed to provide new perspective to inspire artists to create more extraordinary results to make the fun parts more fun.
That's really cool. And so is this what you're going to start focusing on next, or now that you've had a taste of working on Omniverse, what are your next big challenges that you're going to tackle?
Yeah. So, I mean, personally, I would like to continue learn more about the workflows of our creative friends and try to see how we can create AI tool to help them. But another thing is I feel like the Omniverse is a great tool to create synthetic data to train machine learning model to solve other problems. Getting training data is often the most challenging task and expensive task in an AI workflow. Wouldn't it be great if we can generate training data, like just use computer program like Omniverse? And also for some scenarios which are important but are just too difficult to capture in real world. The physically grounded rendering capability of Omniverse provide a way to create high quality training data that would be otherwise difficult to capture in real world. And I think they are very valuable to AI researchers. And we can even tune the scene to get the most useful scenario to train our AI model. And more importantly, rendering and simulation are optimized in Omniverse. It's super fast. It means that you can produce large-scale training data quickly. And this is especially for the important problem where you usually need more data in order to get better results.
Wow. So lots of potential there. And so, Rob, I want to bring one of something that Ming Yu said kind of in the middle there. I'll ask that to you second. But first, just so the audience knows, you joined as a new hire in November and then went straight into GTC crunch time, which we all love at NVIDIA. We have a GTC diet. And we all, save our vacation post GTC. And so, our 3D experts and artists in-house are the most in-demand resource for GTC. And so it was really cool in the documentary to see you ramp up on Omniverse and integrate it into your workflow, and you're super productive with it already. And so you have expertise with using multiple apps. You mentioned Houdini and Maya were a couple of them. And so what aspect of onboarding quite quickly into Omniverse had the biggest impact on your workflow as an artist?
Right. So, yeah, I came in November 2020 and then GTC happened. So I was like, oh, okay, cool. And they were like, yeah, we're going to render everything in Omniverse. And I was like, well, what's Omniverse? So the team started to let me know more and more about what it was doing, why we were doing it. They were giving me a lot of support in terms of what is possible now, what was going to be eventually be possible. So I have a background in photography. So I'm very, very familiar with having a subject matter, whether it's a product or a human, sitting in front of the lights, and I'm able to move the lights, move the person, the subject accordingly, and sort of make some really on-the-fly decisions in terms of where does this highlight sit? Where does that shadow fall? Is it aesthetically pleasing? How can we make this look really, really beautiful? So the fact that Omniverse feels like a virtual photo set, which everything is live. So when you move a light a little to the right, a little to the left, you see in real time how that's affecting your subject. So I'm not waiting to kick off a render and 15 minutes later see how it looks. I can immediately evaluate, oh, okay, this looks great. Especially like GTC was so fast. There was so many iterations and the feedback was coming back and forth really, really quickly. So have that removed from having to send a render off for 15 minutes was crucial for us. So I was able to move a light, send it to the designers, get approval, and then move on to the next slide. And like I said, there were over 100. So there wasn't a lot of time to kick something off and then wait around. So all in all, it was really cool. It was really awesome to be able to bring my problems to the developers who were actually listening to artists. So that was awesome. A lot of times you run into those technical issues and you're like, yeah, I wish it would do this, and it just won't. And then they'll give you little tips. So like, oh, well, you could do this and optimize that. And you're like, oh my God, thank you. So that saved you half a day or even a day worth of having to explore or, experiment. So although it was very, I would say, trial by fire, it was really fun because the team was so collaborative and everybody was really helpful and everybody's trying to find answers and find solutions. And I'm always going to be excited when I'm in an environment where everyone's trying to learn and help each other. So yeah, I survived GTC 2021.
Well, our next one's right around the corner. So
Madison?
Yeah.
May I? I think maybe for a lot of our audience, they know, but they don't really appreciate how painful it is to create images using 3D technology. Just that render time waiting to make a tweak and see what comes back, and then do another tweak again, and place your bet just right that you did the right thing and didn't waste half your day waiting for this render to come back. That's extremely painful. If you could imagine, it would be like a musician who is composing some music, and when they press a key on their keyboard, they have to wait 10 minutes, an hour, a day before they can hear that sound come back, before they can go combine it with the other sounds. So our dream with Omniverse has been to make the creation of imagery, to create the creation of video and all of this beautiful stuff as fun as like a jazz band playing together, getting that feedback in real time. And it warms my heart to hear Rob saying this about the photo shoot, because that's precisely what our goal is. We're not done yet, but it looks like we're on track to achieve that experience.
Yeah,
And
it's very,
I
very
think
cool.
Go ahead.
So the way we split up our tasks for GTC was one of my coworkers would lay out all of the assets, so the panels, the hardware, and then the fact that I was able to just come in and start lighting it and try to find the aesthetic that was going to be pleasing to those products or objects was amazing, because like Rev said, it's almost like you have a photo assistant in the studio with you. And so you're focusing on one part, which is capturing the image, but you have all of this help and support from the other team, and you're not stepping on each other's toes. You're actually working together, and that makes the journey to creating something like this actually pleasant.
Yeah. I think that also ties into kind of what Mingyu said about, and I don't know if you agree with this, Rob, there's the fun part of being an artist, and then there's the boring part of being an artist. And maybe those 100 iterations and the long render times and, having to bake and then edit and then bake again, edit again. How do you see AI being integrated into your workflows in the future? Or do you see AI being integrated?
Absolutely. I'm all for AI. Anytime it can eliminate the human repetitive techniques or things that we have to do, that's amazing. Sometimes it's just a matter of changing a sample setting. And as an artist, you have to decide, is it too many samples? Are there not enough samples? And AI being able to evaluate a scene to optimize it in a way that we don't have to worry about that part would be crucial for us. Because once again, it's always you're changing some settings and then you're hoping that it's going to be, suffice for a beautiful render. But having a computer evaluate a technical scene and let you know, well, this light is going to bounce 6 times, so we're going to automatically change the samples to this to accommodate that, would be absolutely brilliant.
Well, I can also see AI. Sorry, if I too intruded. I can also see. Yeah, sorry. I can also see AI really useful for production as well for the artist. For example, we are working with the Digital Human project, right? So in order to rig up the digital human physically accurately correct with the human body, it's extremely difficult, right? However, if we have AI and then we can trade the network to rig up all the joint and then all the tendon, everything for us. So that will save the artist huge amount of time to improve the production hugely, dramatically.
Absolutely.
Wow. So we have a ton of audience questions. So I think that maybe we'll turn it over to them now.
Let's do it.
That way we have enough time. So where did you take the inspiration of the name Omniverse from? Well, Rev should take this one.
That's a good question. So when the idea of Omniverse had been building and forming for a long time, in some ways you can say since NVIDIA started, we've been barreling towards creating this. But about 3 or 4 years ago, we gave it a name. I put this forward to the team, saying what we want to build is something that can connect many universes together, kind of the superset of all of them. And I proposed multiverse. Most of us around here are sci-fi fans, but one of our employees, who is much more of an expert on the terminology of sci-fi, said, well, technically it's not a multiverse. What you're describing is more of an omniverse. There's ultraverses and there's tons of verses out there. And we thought, okay, we didn't want to call it a metaverse because there will be one big metaverse. Omniverse actually fits what we're trying to do here, which is connecting all of these islands of universes together. And we settled on that. The rest is history.
Well, good thing you had the answer for that. Being here 2 decades, I guess, you've seen the history. Just kidding. All right, then the next question. All right. In the muscle simulation, is the muscle simulation we see real time? Can you put skin on it? And have you ever tried putting clothes onto it in real time? I'm assuming this is for Michelle.
So for the muscle simulation we see in the Keynote, I'm afraid that one is not real time yet. But because as you see, right, we are improving our FEM tech at the moment, and those tech just available in Omniverse. So we're still in a development process of it. However, as you already see in the skeleton hand with the articulation system, and then we put lots of FEM muscle on top, right? So those are all on real time. So it's just a matter of time. I think we will be able to simulate the whole digital human using all the muscle and tendon, and even also put skin on it. Definitely, absolutely possible, because that is really one of our next goal. We will try to do that. So the first step is we build up all the foundation in Omniverse. We were able to let all the other people build the tool with us and build all the application on top of our tool, so we can test out everything. Also, one thing I want to mention as well. So the question is mentioned about the muscle simulation, and also in the Keynote, we also show the tendon simulation as well. So that is the tendon, and you can attach it to the muscle and then pull the dynamic on it. So we are getting up all the tech, able to do all this in real time. So that's extremely exciting.
I'd like to add to that. What we're doing with physics in Omniverse is analogous to what we're doing with rendering. We have multiple rendering paths inside Omniverse. We have the iRay renderer, which is an extreme simulation, as physically accurate as possible with spectral rendering and all of this stuff that you don't need most of the time just to create images, but you do if you need to actually do a simulation. We have our path tracing mode, which is the reference of what would be the most correct given that set of algorithms. And then we have the real-time mode, which makes approximations trying to converge to the reference, but within a limited amount of time. We're doing the same thing with physics. We're simultaneously working on doing the reference, which isn't necessarily real time, but which we can use as ground truth as the bar to achieve with real time. And then we're also doing real time physics. We can also use this reference potentially to train AIs to help us do the approximations and crossover into the real time world. So you'll see all of this coming in Omniverse over the next year or two at different levels of performance and fidelity and quality, but all of it, all of the technology we're creating weaves into the same thing, same goal, which is to have highest fidelity, most accurate physics simulation as fast as possible.
Oh, I missed one part. It's can we even try to put in close on the muscle? The answer to that is yes. That will be our highly accurate FEM-based cloth. So we're working towards the productize that and integrate that into Omniverse. That will be, I think, will become in the maybe next year or two. So for this release, our focus is on the deformable body. After that will be our particle system, and after that, we will refine our FEM-based clock, and then hopefully at that point, we can dress up any digital human you want, physically accurate.
That's great.
And that's really exciting.
It is. That's why I'm hoping for all the we can utilize all the GPU power, because you think about FEM-based clocks, right? A high fidelity clocks can be thousands of elements in there. And also the muscle simulation, it's FEM-based as well. If we do a really high fidelity digital human, maybe millions of small tetrahedron in there. So we do need to have the power of GPU in order for us to push all this tech in real time, cost the life.
Great. When training cars in the virtual environments, do you introduce any sort of chaotic behavior seen in the real world? I don't know what level of chaotic behavior, but
yeah, I think maybe they mean random, random behavior. In general, when training AIs, you want to do what's called domain randomization, where there's a domain of inputs, this large space of inputs that you could put into the AI to train it. And you want to have a diverse set of inputs in there, but also the right subset, stuff that can possibly happen. So the things that your AI learns are relevant to the real world. If you overfit it to a very small part of the domain, then it won't be very smart. And when it encounters something that's out of the ordinary, and potentially in the case of something like a car, maybe a child running across the street, while a volcano is erupting and ashes spewing everywhere, these like unlikely scenarios that we want to make sure if they ever encounter it, the car does the right thing. It won't do the right thing if you don't train it that way. So absolutely, we are hyper focused on creating enough diversity of data. We actually believe the only way to really do this right is to synthesize it. And to do that, you need simulation. And to do simulation, we built Omniverse for this purpose. You can't go capture all of the data you need to make really smart AI, because in most cases, not only is it not possible, it's unethical. We're not going to have children run across the street during volcanic eruptions just to capture the data in the real world.
I guess this is also, kind of what Mingyu was talking about in his answer to the last question, was about the opportunities for synthetic data generation.
Yeah, and also you can use this to create, to test your AI system. very fast to understand where to further improve. I think this is a unique opportunity to use simulated data to improve many AI tasks.
Yeah, this is where Mingyu and Rob actually have the same problem. He doesn't actually know what data he needs to create his AIs. So he has to create his data set and go wait for that data set to appear. Either we grab it from the real world or he has to synthesize it. And then once he trains his network, he can then test to see if it performs well. And if it doesn't, he has to go back and generate more data. So the tighter we can make that loop, the more iterations we can have, the better the final product is going to be, whether it's a beautiful image or an intelligent AI. It's really fundamentally the same problem.
Yeah.
I don't know, Rob, if you want to validate the statement or.
That is absolutely 100% accurate.
Okay. Awesome. Well, excited to see where it goes next. Do we have another question? Does an artist really need all that other Omniverse tech, physics, AI, etc., do you think? Or is the platform too complex to be for artists? I think this is for Rob.
So I am big on versatility. So I don't really care for a very narrow way of approaching anything. I think the more versatile you are, the wider your gamut is of understanding of anything, whether that's language or art or music. I think the better you'll be able to recreate or make something based on reality. So although every 3D artist isn't an effects artist and every effects artist isn't a lighting artist, it helps when you're able to tap into any of those semi-related techniques in order to better your discipline. So I personally love fabrics. Like, I'm all about fabrics, knit, that's my jam. I'm all into it. So, but I also love lighting, and I also understand that in order to have a really believable piece of cloth, the physics has to be accurate or the cloth won't look right. And if you have a, I guess, accurately simulated piece of cloth, but you don't light it properly, it's going to be ugly to look at. So they kind of work hand in hand. So you can't really disconnect one or the other and expect to get something that's absolutely amazing. So I think it's great that Omniverse has physics built into the system. Even if you don't need it, I mean, okay, we don't always use every button in our car, but it's there. You don't always use your airbag, but when you need it, you know, you're very happy that it's there. So I think artists are going to benefit regardless, whether it's you've mastered lighting and now you want to explore something else. All right, let's try some fluid simulations, or let's see what these particles is all about. The fact that you're able to do that without having to go to another piece of software is absolutely amazing.
Yeah, I think coming from where 3D has been, you know, with the limited computing capabilities we've had, and where our algorithms have been, the idea of having all this other stuff like physics seems like it's more burden on the artist. That's generally how it is in the tools. You have to really be an expert in each of those things to use that well. But I think we are crossing a threshold now where we have enough computing power so that the tools can actually become easy or trivial, especially if we combine it with AI. So stuff like I've been doing 3D since I was a kid in the 80s, and I still can't place objects on a table and stack them in 3D by hand and have it look natural and correct. Laying down a book against some object, I can't do it. It takes like an artist to do that right. But because we have physics simulation and we have this feature in Omniverse called zero gravity, we can use PhysX to naturally lay out the scene, and anybody can do that without being an expert in positioning things in space so that they look natural. With cloth, I mean, just draping a cloth over a sofa or some other object, if you were to do that by hand in a model without physics, it's terrible. It probably won't look correct. And if you do get it right, it's going to take you days and days to do that. So simulation can actually help you here. We just need to have a lot more of it. It needs to be accurate and easy to use. Performance is critical for that. And so we're hoping to get there. Omniverse we're just at the beginning of that journey with Omniverse.
And to follow up, Michelle, you had mentioned, game development, robotics for physics. Did you ever expect that artists would find physics so important?
If you asked me a few years ago, the answer is no. But now, clearly, right, it's extremely important. As Red mentioned, we have some tool called zero gravity, right? So in zero gravity, we actually, when you place the object, like what Red described, right, we run the constraint system in VSET itself, right? So we depenetrate any of the penetration. So the artists don't need to actually spend so much time try to, small steps, try to move the object, the placement of the object to be correct place, right? So that actually save a lot of time.
That's like the biggest
artists.
problem in all 3D is making sure
exactly.
objects don't overlap with each other, that they don't penetrate
exactly.
to each other. So much time and effort is spent on this one thing, and it's like the unsaid huge problem that a little bit of physics simulation, something that's trivial for Michelle's code to do, can solve instantly.
Yeah, that's pretty cool. And also, as Red mentioned again, right? So we have a crawl and all maybe soft body as well. If the artist want to play with all this toy, right? They put a place in there and then just run the simulation. Everything fall to places, right? And it's beautiful. And you can choose all the right material, right? Because we're using FEM base, so you can actually check up the material property in even a textbook to simulate, just like say, seal material and leather material or whatsoever. So we are able to simulate all the physical stuff that accurately now. So that's extremely exciting.
Well, I guess the underlying theme here is basically Rob won't have to do any of the boring, annoying stuff really soon.
Rob can just be work in his photo studio. It just happens to be in the metaverse.
Yeah. So we expect maximum fun part, creativity next time, since now all of the boring stuff is taken care of. All right. Next question. We always talk about the metaverse in relation to businesses, but when will art, gaming, and AI come together in the metaverse? Maybe Rev, you just spoke on building the metaverse, a panel hosted by Epic. So maybe you want to take this one first?
Well, I'm not actually quite sure what the question is trying to get at. I believe they are already coming together. So my view on the metaverse is that it already exists. It's just evolving. In the same way the internet existed in the 70s, but most people didn't find out about it until the 90s. It was there. It was there all along. It's just growing and evolving and changing. The web appeared in 1993. A few years later, it became really big, and here we are now. I believe the metaverse was being constructed this whole time. Everything we've been doing in video games, in visual effects, in designing virtual worlds has been contributing to this. And now they're starting to come together. And everybody's doing their piece of this. Companies that build tools to design buildings, companies that build AIs to push our robots, companies that make video games that you can now have concerts in, like Epic and Roblox. All of us are fundamentally doing the same thing. We're building our corner of this metaverse. And the internet already exists, so we're starting to connect. And we're just trying to figure out how to connect these things better, how we can really do everything in there. We don't want to limit it to just playing in there. We should be having this conference, this question and answer session here together in something that's more embodied, where we feel we're inside that virtual world, and we should be able to work in there. and do all of our work inside the metaverse, go in and out of it as we see fit. So I don't think it's about when it will come together. It's already happening. We can't predict how fast, but I think we can look at history with the World Wide Web and see where we were in 1993 when HTML 1.0 was introduced in the first web browser, and where we are today, and kind of go, all right, if we believe that the metaverse is the way it's going to happen, the way we describe it, it's going to be at least as big as that. And I would argue that it's going to be much bigger. So most people couldn't imagine it in 93 where we'd end up now. I don't think most people can imagine where we're going to be 20 years from now, or I guess 28 years from now. But let's go. Let's just start building it piece by piece. We're laying down the bricks.
Awesome. All right, next question. I think we have maybe one last question left. What is the future of VR in Omniverse? I think actually, this relates a lot to, there's a lot of definitions about what we need in order to be the foundations of the metaverse. And in order to be a metaverse, there's an element of VR and AR that needs to be involved. I think a lot of critics have written about that. So this is interesting. What's the future of VR in Omniverse? Maybe for Rev?
Yeah, so we already have basic VR capabilities available even in the open beta. You can enable it and use it with a HMD and headset. We actually believe the path we've taken with our renderer is the right path for the future of VR because it's completely based on RTX and ray tracing. Ray tracing is very flexible, and we can decide to do more work in generating the parts of the image that matter based on what you're looking at, using foveated rendering and all of that. We have quite a bit of effort going on in-house right now to build out more of our VR and XR capabilities. Stay tuned. There'll be more announcements coming. A lot of what's inspired us to build these different parts of Omniverse came from a project we did years ago called Holodeck, which is all about VR and collaboration and design inside a virtual space using VR technologies. So we haven't lost sight of that. That's all in the works, and we'll be there soon.
Great. And so we are out of time. So thank you everyone for joining. And we did just release or announce that GTC is coming up in November. So see what all of these folks on the line have in store for you next. I'm sure there's going to be a lot of exciting things. And Rob is going to maximize his creativity since Mingyu and Michelle are helping him do his job for the boring stuff.
That's right. I cannot wait.
We should also mention that if there were questions that were unanswered, they can come to either the Omniverse forums or our Discord, and many would be happy to continue the conversation there.
Yep, and we are launching our inaugural Omniverse user group, so you can interact with the engineers, developers, artists directly in a couple of breakout rooms after the user group, and you'll get some sneak peek previews to some of the exciting tech that we're Easter egged across this whole Q&A. So thanks, everyone.
Thank you.